On March 17, 2026, the night sky over Baghdad lit up. The counter-rocket, artillery, and mortar system, or CRAM, defending the U.S. Embassy, unleashed a wall of kinetic fire, pumping out 4,500 rounds per minute. Despite that curtain of defensive fire, multiple drones reached their targets, striking the heavily fortified concrete compound. Across the Persian Gulf and the Strait of Hormuz, mapped here, this saturation is widespread. Expendable munitions are consistently penetrating multi-million-dollar defense networks, from the UAE to Kuwait. If a localized defense system can throw thousands of high-explosive rounds in a matter of seconds, how are cheap, slow-moving drones consistently slipping past it? Evaluating the effectiveness of this defensive shield requires a forensic look at two distinct attacks on the Baghdad embassy. The CRAM is a land-based adaptation of the Navy's Phalanx close-in weapon system, shown here. It was originally adapted during the counterinsurgency campaigns of the 2000s to protect bases from the predictable parabolic paths of unguided rockets. At the absolute core of this defense architecture is the M61A1 Vulcan Gatling gun. The system relies on calculating physical laws, tracking the simple arcs of incoming artillery shells to put a wall of 20mm shrapnel in the target's path. The 2026 battle space presents a different threat profile. The Iranian military and its proxies are mass-deploying kamikaze drones like the Shahed-136, equipped with jam-resistant navigation. These loitering munitions are programmed to fly at extremely low altitudes, hiding behind natural terrain and urban clutter. This approach exploits the radar horizon, which has shrunk the defensive reaction window to just a few seconds. A machine engineered for predictable ballistic equations is now colliding with maneuverable, intelligent aerospace systems. On March 13th, proxy forces executed a precise tactical bypass, avoiding the CRAM's firepower entirely. The Gatling gun is an effector that depends on its integrated Ku-band tracking radar to function. The Ku-band radar is a high-frequency sensor that establishes a firm lock on targets at short range. In the opening phase, attackers targeted that sensor node. A precision strike neutralized the radar, blinding the battery. With the sensor dead, subsequent drones flew right past the inert gun, striking the embassy's helipad and a critical satellite communications array. Days later, on March 17th, the complex faced another intense barrage. This time, the radar was intact. The system successfully acquired, tracked, and shredded at least 2 incoming drones mid-air. Despite the system performing as designed, a third drone survived the kinetic wall, slipped past the interception envelope, and detonated inside the compound. Swarm doctrine organizes multiple munitions to approach from different axes simultaneously. The goal is to force the defense network to engage on too many fronts at once, intentionally exhausting its processing logic and its ammunition reserves. While the CRAM remains lethal when its sensors are operational, its deployment has exposed a deeply asymmetric cost-exchange ratio. Iran is mass-producing Shahed-136 drones for roughly $50,000 a unit. Using a multi-million-dollar theater defense asset like this Patriot missile battery to knock out a cheap kamikaze drone yields a mathematically unviable war of attrition. Relying on high-end interceptors to counter thousands of incoming threats is draining ammunition stockpiles across the Gulf, creating a severe logistical strain on U.S. forces worldwide. The U.S. military is pivoting mid-conflict to address this. They have reverse-engineered recovered Iranian technology to deploy their own low-cost drones, like the Lucas, to strike launch infrastructure. The long-term solution to the ammunition limits and economic drain lies in directed energy weapons. High-energy lasers offset the advantages of massed drone swarms. A directed energy system can fire a concentrated laser beam for an operational cost of about $3.50. As long as the platform has generator power, it possesses an infinitely deep magazine. Viral videos of blazing 20mm Gatling guns project an image of absolute security. However, the brutal mathematics of swarm warfare dictate that survival requires a shift toward integrated, cost-asymmetric defensive technologies.